Hello, I'm Jem Park, and I will be teaching on 5 and 6 days lecture. On day 5, we will learn what the function is and how to use it. Based on this, we are going to find out what the module is today. If you have any questions after today's lecture, please use the Q&A bulletin board on Notion page. Day 6 lecture consists of 5 steps. First, let's find out what modules are and how they can be applied to future tasks. First of all, what is called a module? A module is a collection of functions, variables, classes, and few more things, a module in a Python file that can be recalled and used by Python programs. A function also contains many functions and variables inside. Module contains many functions and variables on top of them. Modules make it easy to communicate and share functions and variables that we use to other. Then why should we use the module? It is similar to the reason why we should use function, as I mentioned before. The biggest advantage is that the code is concise and easy to manage. Suppose we insert a group of functions aims to do a certain task. But let's say the purpose of the program has changed and the code needs to be modified. Then we have to revise all the codes one by one. This is very inefficient and easy to make errors. However, if we implement key roles as a function and manage them as a module, it is very simple to solve because we just have to choose the functions that we want to change and change them only. Let's also imagine when we work with many people together on a project. In this case, people often use the same functionality. Maintenance can be difficult if different people implement the same functionality with their own different codes. Also, compatibility with other people's code is not good. However, if you create and share your module, all the people would use a function in a certain format, so regular coding is possible. Since it has so many advantages, it is best to use a module unless a simple code. So far, we have learned what modules are and why they should be used. Based on the explanation so far, I think you can fully predict what the module will be like. Now let's find out how to make a module. I've described that a module consists of functions, variables, classes, etc. So you should declare functions, variables, and classes in Python file. We created a module called math module by collecting the functions that we made last time and the functions that check if it is an odd number. I think there are students who will practice in person while taking this class. If you're writing code in Jupyter Notebook environment, it will save with the extension .ipynb by default. However, the module must be a Python file, so must be saved again as .py in the Jupyter Notebook. Just click on File and Download as and .py for anyone who writes Jupyter Notebook. The module must be in the same path as the file we want to run. You will learn how to use the module even if it is in a different position on later slide, but by default, it must be in the same position before you use. I saved the file mathmodule.py with the same space with lecture6.ipynb that I just created. Now let's create a file to use the module. Let's write the lecture6.ipynb file that came out earlier. Use the command import to use the module. Write import and write the name of the module we will use afterwards. When you write the name of the module, you don't have to write .py, just write the name. If there is no reaction when you import it, it was written correctly normally. If there is an error message, this means that the module is not recognized normally. So you can solve it by the error message. To use the function inside the module, write down the module name and period and write down the name of the function, variable, etc. that we will use. If you want to use the additional function in math module, we can write down math module.add xy. The picture below shows that all functions in math module are called normally. Usually, if you look at open sources, there are a lot of functions in one module. So there are times when we want to get only a few functions and use them. For this purpose, Python ensures import certain elements from within the module. It is done by using from. Write from and write down the name of the module, import, and the name of the element to import. The element to be imported can be a function or a variable. If you look at the picture below, it means that you want to import only the function add from the module math module. Because the function add is imported, the value of 3 plus 5 is output normally. You don't need to write the name of the module before add, because we didn't bring the entire math module. Use only with the name of the function. Since we didn't bring sub from math module, when you call a sub function, you can see that the error appears saying it is an undefined function. This prevents unnecessary functions from being imported and prevents confusing in code. So far, we have shown how to declare and use functions in modules. However, you can also declare variables in the module. I saved the circumference and natural constant values in math module. Don't forget to save it in Python file and save it in the same path to test it. Let's import the module that stores the circumference and natural constant values and check the values. You can also write the name of the module and then write the name of the variable as functions. As you can see from the picture below, you can see that the values are output normally. Modules can also be used by adding classes. But since we haven't learned about the class yet, I want you to learn about it and practice it by yourself. In fact, it will be easy to use because there is not much difference with function. When using modules, there are modules with fairly long names. Entering such a long name many times is quite cumbersome. To do this, we can set how to call the module during the import process in Python. As shown in the example below, instead of the long name math module, you can replace it with the short word mm. Write the import module name, and after that write as and the same name we want. This will only be valid within the Python file that has imported. Suppose we want to get the circumference value in math module. Then we have to type the long sentence math_module.py to get the value we want. However, if you define the name of the modules as mm.py will give the values with simple statements. If you use it properly, you will be able to write the code much more concisely. This feature only changed the name of the module, but there is no functional difference. You should be careful when using modules defined by different names. If you import a module within a different name using as, an error occurs when you use the name of the original module. That's why we need to know exactly what name we defined and write the code. Modules can also be used in other modules. This means that there may be a module in the module. Let's make a new module using the file called math module that we made earlier. The module below is called math module expanded. Math module was imported to create a new function called print_pi. Within this function, we used a variable called pi, which is the circumference value of math module. Save this code as a Python file and save it in the same place as the main code. Now, let's use our new math module expanded. Let's import the module using import and run the newly created function print_pi. You can see that circumference values is printed normally. Then, if there is a module in the module, can we use the functions or variables of the first module? The answer is no. Let's call the pi variable in math module when we get the math module expanded module. You can all see errors occurring. Importing other modules from the modules we imported does not mean that we can use them all. That's why you have to import the modules again before using them. You may be a little confused with the inheritance that will come later in the course. So far, we've learned a number of ways to use modules. Let's now learn what the results are based on the variable name when you run Python files at the command prompt. Let's create a simple module to learn about the variable name. You have created a module named mode1. Let's create an add function that adds inside the module. And let's write a code that outputs values of 2 plus 4 and 12 plus 7 on the last line of the module. Save it as a Python file again. And let's remember the path is Python file is stored. Now, if you're using Windows, let's open a command prompt, and if you're using MacBook, let's open a terminal. If you're a Linux user, If you look at the picture, you will know what to do, so I won't have to explain it. I'm using MacBook, so I took the picture based on MacBook, but you can use the same command language. First of all, let's go into the directory where mode1.py file that we created. Move to where we want to go with the cd command, then enter Python environment by typing Python. Now let's type import mode1 and see what the result is. As expected, we can see that the values of 2 plus 4 and 12 plus 7, 6 and 19 are printed normally. But we don't want that output to come out when we import mode 1. So I'd like to change the code a little bit. Python has a special variable called name. If we run mode1.py directly, main is stored in a variable called name. If mode1 is imported from another file, it will be saved as mode1 in name variable. Use this principle to output addition results only if mode1 is executed directly. Let's use the if statement to change the code to output if the name value is main, and save mode1 file as Python file again. Now let's open the command prompt or terminal again and get all the way into where the mode1.py file exists. Type Python and import mode1 in the same way. Now you can see that we are no longer printed 6 and 19. Instead of importing mode1.py, if you run it directly, the name value will be main and the calculation results of 6 and 19 will be printed. So far, we have looked at various ways to use modules. However, I have always said that we need to be in the same position to use the module. Now, I'll show you how to run the module and the files you want to run, even if they're all in a different place. In fact, this is a little far from learning Python grammar. However, it is useful to learn and it is also related to setting environment variables when installing Python. The first way is to use a module called sys, which is basically provided within Python. By default, when Python is installed, several modules are installed as well. One of them is a module called sys. Sys modules are modules that allow direct control of variables and functions provided by Python interpreters. Open a command prompt or terminal to proceed, then write Python and import sys. And let's open sys.path, which shows the path where Python library is installed. If you type sys.path, you will see all the paths to the libraries we have. This may appear differently depending on which libraries you have installed. If you put the path of the module we want in this path, we can always import Python files and modules even if they are not in the same place. This .path is an array after all, so use .append to add the path of the module we want to pass. And if you check this .path again, you can see that the path we entered has also been added. And if you try import mod1 again, you can see that it is working normally, even if though it is clearly in a different path from the module. You can also use an environment variable called Python path to specify a path. Write down the set command and the path to the module. Lastly, I will briefly explain the package, which is a set of modules. A package is collection of modules in layers. If the module was a Python file, the package contains layers of these Python files, and we also need init.py additionally. The famous Python open sources are often in a form of package. However, it is out of our scope, so we don't deal with in more details. It is recommended that you learn more about the class before you search on this. Today, we learned about modules. Modules like functions do not actually determine whether a program does run. However, it is an essential feature for more efficient and neat coding. Now that we're writing a simple program, we don't feel the need for modules. But if we are writing a program to solve real-world problems, we need a lot of modules. Also, it is essential to understand in order to learn the following contents. Thank you for taking the class today.